Create assembly file. I have already created parts for this animation in the parts container. Connecting rod, piston, bottom part of the connecting rod, a pin, and the crankshaft. Major dimensions of these parts are piston, 49 mm from the center of the hole to the top, connecting rod 168 mm long from center to center, 54 mm diameter for the bottom ring. Crankshaft, the cramping channel is 24 mm diameter and is 35 mm from the center line. Add 12 mm to the position of crank pin as the location of the connecting rod. So the positions are 78, 102, 180, 204, 282, 306. Each clamping channel is 20 degrees apart within each pair. The first, third, and fifth counterweights are 120 degrees apart. Create variable. Angle. And create the LCS for positioning the piston in the assembly. Select the LCS origin. Duplicate. Uncheck X-axis. I need total 6 coordinates. Duplicate. I can duplicate all 3 LCS at the same time. So I have all 6 LCS. After I duplicate these LCS, I need to move them to the assembly. Otherwise, they are not visible in the parent assembly. Select all the LCS. Move. So now they are under the assembly. Create a new assembly file. Under the assembly, create a new sketch. Call it master. Use the default LCS. Model, LCS, paint face, OK. Go to the sketch. Create a construction line from the center. .300 mm long. 60 degrees from the axis. Draw a line from the center. 35 mm. As the crank pin channel is 35 mm from the center. Draw another line. 168 mm. It is the length of the connecting rod. Draw one more line, 49 mm. It is the length of the piston. Set the angle of the 35 mm line as variable angle. Add the LCS to the master sketch. First one is piston top. Select the top line. Z tangent to edge. Select the top vertex. Move the LCS to the top. Create another one for the connecting rod. Select this line. Z tangent to edge. OK. Add the LCS. Change the map path parameter to 1 to move the LCS to the top of the line. Now I can insert parts from the assembly to the sub-assembly. Insert piston. It is the piston top. OK. Insert pins. Select piston body. Piston. Pin. OK. Connecting rod. Insert. Parent assembly. Connecting rod top circle. OK. Connecting rod. Bottom center. OK. Insert screws. Insert screw. 2 screws are inserted. Make it 30 mm. Insert nut. It is 31 mm from the top. Insert nut. Minus 31 mm. Change the color to blue. Close. Change the color. Close. This sub-assembly is finished. There are 6 sub-assemblies with same construction, but the motions are all different, so I need 6 sub-assembly files. Save these as new files. The first, third, and fifth are same construction with a different motion. Save this file as number 3 and save it again as number 5. I have 3 sub-assemblies now. And then change the sketch. change this angle to 120 degrees. OK. Save this subassembly as number 2. Save as number 4. And save as number 6. Now I have 6 subassembly files. Open these files again. Open number 1 to number 5. So there are 6 subassembly files with 2 different constructions. Now I adjust the motion for each subassembly. The first one is good to go. Modify the second one. Go to the Sketch Master. Change the angle of rotation. To angle -20. For the third one, change it to plus 120 degrees as the counterweight is 120 degrees apart. For the fourth one, as the fourth one is a 20 degree behind the third one, so add 100 to the angle. For assembly number 5, change the angle to angle plus 240. The final one, number 6, the 6th is 20 degrees behind the 5th, so it is angle plus 220. All 6 assemblies are ready now. And also 6 coordinate systems for the pistons. So I just attach the assemblies to the coordinates. Insert the number 1 parent assembly. Match number 1 to the origin. Insert number 2 parent assembly. Need to change the position of the LCS first. The first one is 78. The second one is 102. The third one is 180. The fourth one is 204. The fifth is 282. The number 6 is 306. C is 78, not X. It is correct now. Insert number 3. Insert parent assembly. LCS origin. Insert number 4. Parent assembly. Number 4. LCS origin. Insert parent assembly. Number 6. Origin. Set the variable angle at 90 degrees. Insert the crankshaft. Parent assembly. LCS origin. Crankshaft center. I set the variable angle at 90 degrees. It put the connecting wall bottom wing at the vertical position. It is easier for me to verify if the crankshaft position is correct or not. Select crankshaft LCS. Set it as variable angle plus 270. As I set the angle as 90 degrees, so there's 90 degree differences between the crankshaft and the first connecting board. The angle at the crankshaft LCS will be minus 90 degrees or plus 270. Run the animation from 0 to 360. If you find this video interesting, please subscribe and give it a like. Thank you for watching.